Good evening, guys. Yeah. So we'll get started. We'll get started with the next chapter, that is three-dimensional geometry. Right. Just a minute. Right. So we'll get started with the 11th chapter. There are two chapters that are left out. 11th is three-dimensional geometry, and the 13th one, that is probability. Right. With that, we are done with your 12th standard syllabus. So, as the name suggests, right, three-dimensional geometry, what do you think we are going to discuss here? Can someone give me an outline? I'm sure in most of your schools, they would have completed it. Is there anyone who doesn't know, who has not learned it in school at all? Can someone give me, speak out? Is there someone who has not learned in school at all? So everybody knows this chapter, right?
Yes, sir.
Okay. Okay, but I will try to give my version of it. Okay, wherever you have doubts and all those things, I'll try to share my thoughts of how I approach problems and all those things. But I'll be teaching the concepts also. Don't worry, I'm not going to directly jump into problems because this is one of the trickiest chapters. But I want to have a discussion with you guys on understanding what is your level of understanding this chapter. So if you see in your 11th standard also, you had three-dimensional geometry. In the next chapter to coordinate geometry, the coordinate sections, that is the straight lines and conic sections, you had something called as three-dimensional geometry. There, what did we learn? So three-dimensional geometry, what comes to your mind? Basically, you will take the three dimensions, that is the x-axis, y-axis, and z-axis, and in that space, so generally one dimension is called as a line, two dimension is called as a plane, and the three-dimensional part is what is called as a space. So if you take the points in the space, then the ordered triplets will be x, y, z. Correct? So what does that x represent? What does that x represent? So x is basically the distance from the origin to the foot of the perpendicular you draw on the x-axis. Y is what? Y is the distance from the origin to the foot of the perpendicular you draw on the y-axis. Z is the same case, right? So that is what we saw. Then what we will do, we would have done in our 11th standard is, we would have taken 2 points, we would have found the distance between them, we would have applied the section formula, these kind of things. Am I right? Right? Is this what happened? But what is the thing you have learned extra in this chapter from your school? At least you would have heard, right? I'm not sure how much you have practiced, but what is that you have heard? What is different that is existing from your 11th standard? Is it a simple thing or is it a very big difference? What is your opinion about it? Guys, discussion will help me to understand your brain better.
Involved.
What?
Vectors are involved in three-dimensional geometry.
Okay, vectors are involved is what you're trying to say in this chapter. Is that right?
Yes, sir.
Okay, that is one thing accepted. But I have another question also. You're taking the help of vectors, but for what? But for what? Why are we taking the help of what? What are we achieving, or what are we trying to find out by using those vectors? How are the questions actually? Let me make my question simple. What are the types of questions that you have? They'll ask you to write the equation of line, right? They ask you the equation of line in a three-dimensional space. So when I say equation of line, y is equal to mx plus c is the equation of line that we know till now. But what is the difference between this line and the one which we are going to learn now?
Just vector
need not be. You mean to say that two-dimensional thing we could have learned vectors in 11th standard itself, and we could have applied it to two-dimensional geometry also. Okay, let me make my question simple. Then y is equal to mx plus c, right? What does m stand for?
Slope, sir.
Then what does c stand for?
Intersection point.
It's called as intercept. Intercept, now the distance from the origin to the point where the line is cutting the y-axis. Okay, that's what we would have learned. But the same y is equal to mx plus c, can I use it for a line in a three-dimensional space?
Sir.
Can I use it?
No, sir, you can't.
Why can't I use?
Because it's a third z, sir.
Perfect. So there is a third parameter that is getting involved, that is z. Secondly, what has happened here is, if you talk about m is slope of a line. But what is the basic definition of slope of a line? M is tan theta. Right, tan theta means I have a right angle triangle. I can always think of vertical divided the ratio of the vertical to the horizontal is what I call it as a slope of a line. Right, but here there is a tricky part that you need to understand. The slope of a line will become an easy thing in your mind if it is restricted to a plane. You can ask me, can I not find tan theta for a three-dimensional space, sir? You can do it, but it is a tedious process. Right, where a lot of visualization comes into picture, and you're restricting yourself to one angle theta. Because here it is easy to try to understand. Okay, if I take theta, then if theta is the angle made by the line with respect to x-axis, then I can say, if it is going to be here, for example, if this is going to be theta, then I can find this angle also by using the basic geometry. It is easy for me. Generally, what does this tan theta stand for? Theta is the angle made by the line with the x-axis, correct? So that is how it works. Whereas in this case, what happens is when you go with multiple coordinates, it is not enough that you have only one angle. That is why, if you see, we don't use a concept of slope at all in the case of three-dimensional geometry. So what is the replacement of slope in this? Can you guys tell me? So always think like this, okay? Tan theta, tan is a trigonometric function and theta is the angle made by the line with the x-axis. Okay? Then I need a trigonometric function and an angle to define a different kind of a parameter in the case of three-dimensional geometry. What are they? I'm already showing it to you.
Alpha, beta, direction cosines. No?
They are the direction cosines. Now, did you understand why direction cosines have come? Because of the failure of concept of slope for three-dimensional geometry. Or else our life would have been even more easier. We need not sit and study all these things. We can solve everything with the already known concept, that is slope. That is why we had to go for the other concept of direction cosines and a proportional part to the direction cosines called as the direction ratios. Okay. And these two parameters, that the direction cosines and the direction ratios, are defined with respect to a line. Okay. So we would have studied in our 10th chapter also. I didn't explain it there. That's a different story. But yeah, if I take a line, okay. If I take a three-dimensional space, x-axis, y-axis, and z-axis, then let's say there is a line which is in the space. Let's say there is a line which is in the space. Then if that line is making an angle alpha with respect to x-axis, it is making an angle beta with respect to y-axis, and if it is making an angle gamma with respect to z-axis, okay, then these alpha, beta, gamma or angles, if you take the cos of those angles, what is cos? Cosine. If you take the cosine of those angles, then those values are what are called as direction cosines. Okay, the reason why we call them as direction cosines is because when you try to apply the vectors concept and see, out of all the trigonometric parameters, it is not like direction sines. It is not like direction tangents, direction secants, not like that. Why are we taking only cosine? Because that is an easier parameter of all the trigonometric functions that are there for us to calculate in the case of a line in three-dimensional space. Am I clear, guys? Am I clear with the introduction? Did you understand the story of why we are reading this?
Yes,
Yes, sir.
Right. So that is what, as I told you, if you have a line L which is passing through the origin, the first point to be noted, and it is making an angle alpha, beta, and gamma with the x, y, and z axis respectively, then these angles are called as direction angles. Then the cosine of these angles are called as, that is cos alpha, cos beta, cos gamma, or what are called as direction ratios of this particular directed line. Okay. Suppose if we reverse the direction of L, then the direction angles are replaced with a supplementary, that is pi minus alpha, pi minus beta, and pi minus gamma. Then the ratio, the signs of the direction cosines also get reversed because cos of pi minus alpha is minus cos alpha. Right. So they get reversed as well. So having said this, we need to understand what these direction ratios are. Okay. If you're able to take any number, any scalar quantity, which are proportional to the direction cosines of a line, then those numbers, those scalar values are what are called as direction ratios. They are called as the direction ratios of that particular line. That is, generally, instead of writing cos alpha, cos beta, and cos gamma every time, we write them as L, M, and N. So if there are numbers which are proportional to this L, M, and N, which I can name it as A, B, and C, then this ABC is what is called as direction ratio. So to put it in simple terms, L divided by A is equal to M divided by B is equal to N divided by C is always a constant, where L, M, N stand for direction ratio, cosines, and ABC stand for direction ratios. Am I clear?
Yes, sir.
Right. Am I clear with this? I'll slowly come into the concept of how to find them. That's a different story. But you need to first understand the definition of it and the actual significance of it. Okay. Then what I can say is, there is something like this: cos square alpha plus cos square beta plus cos square gamma is equal to 1. Do you guys know this? Do you guys know this? See,
No, sir.
it's very, yeah, okay. If I take a line on which there are 2 points, x1, y1, z1, and x2, y2, z2, okay. For simplicity purpose, I'm taking that this line is restricted to a plane where this line is making an angle alpha with the x-axis. Okay. So if I drop a perpendicular from here and here, then tell me one thing. What is this distance, guys? Is it not x2 minus x1? Right. And if I take this distance as AB, similarly, if I drop a perpendicular onto the y-axis, then this distance will be y2 minus y1, accepted. Now, if I take this as alpha and this as beta, don't take it as 90 minus alpha, okay? If I take this as beta, for your understanding, I've taken it in 2 dimensions. Now, what is cos alpha from this triangle? If this is alpha, this is also alpha, because they are corresponding angles. Then what is cos alpha? Cos alpha will be equal to x2 minus x1 divided by AB. Similarly, what will cos beta be? It will be y2 minus y1 divided by AB. Then what is cos gamma, guys? It is Z2 minus Z1 divided by AB. Am I clear till this point? Right. Then if I square them and add, then cos square alpha plus cos square beta plus cos square gamma will be equal to x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole divided by AB square. But what is AB? What is the distance between two points on a line? Root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. You know this, right? So
Yes, sir.
this one and this one, they both are same. When they get cancelled, that is the reason why you get 1. So if you already know the reason, well and good. If not, you can make a note of this. So that is the reason why we say L square plus M square plus N square is equal to 1. Okay.
So I have a doubt in the previous formula.
Tell me.
The L by A, M by B, N by C.
That is not a formula. That is a definition. This is
Well,
not
that's
a
only
formula.
for definition. So we won't use it in any question.
Sorry?
We won't use it in any questions, sir.
Yeah, you will use it. You will use it. But I'm trying to say L, M, and if you call L, M, and N, if you call them as direction cosines, and you randomly name 3 numbers as A, B, C, and you call them as direction ratios. Okay, I give 2 names, sir. In your left hand, I give you direction cosines, and in your right hand, I'm giving you direction ratios. Then you take the corresponding direction cosine and direction ratio, then they are in the same proportion. That is what they're trying to say. Now read the definition. You take any 3 numbers, and if those 3 numbers are in proportion to the direction cosines, okay, then those 3 numbers are what are called as direction ratios.
Okay, sir.
Okay, they can be any 3 numbers. Is it clear? Am I clear with this derivation part?
Yes, sir. It's clear. It's clear.
That is clear, right? Okay, good. Okay, let me go to the next step. Since you asked this, let me tell you. L is direction cosine. It is always proportional to a number which is called as A. Why I'm saying it like this is because if you see cos alpha, x2 minus x1 divided by AB is what I got. Correct? Cos beta, what did I write? y2 minus y1 divided by AB. Did I write it like this? Similarly, cos gamma is equal to z2 minus z1 divided by AB. Correct? So can I write this as 1 by AB times x2 minus x1? Can I write it? This is 1 by AB times y2 minus y1. Can I write it like this? This is 1 by AB times z2 minus z1. So whether you take cos alpha, cos beta, and cos gamma, there is one thing that is common to all. Rohan, are you able to understand what I'm trying to say?
Yes, sir.
So cos alpha is what is L, cos beta is what is M, and cos gamma is N. L, M, N are generally used to reduce your burden of writing cos alpha, cos beta, cos gamma every time. That is it. That's it. Okay. So can I say L is proportional to x2 minus x1? I'm not using L is equal to 1 by AB into x2 minus x1. That is, if I divide L and M, that is L by M, what am I going to get?
x2 minus x1 by y2 minus
by y2 minus y1. If I rearrange this equation, L by x2 minus x1 is equal to M by y2 minus y1 will be equal to what? N divided by z2 minus z1. If you want, you can divide M and N and see that is what you're going to get. Correct? Then can I say this direction cosines LMN are proportional to some number called as x2 minus x1, y2 minus y1, and z2 minus z1? This x2 minus x1 is what I'm giving a name called as direction ratio. This is B and this is C. At least now Did it make some sense?
Yes, sir. It made sense.
Now is it clear? Yeah. So, yeah. So L is equal to A times K, B is equal to M times K, and C is equal to N times K. But we know the fact that L square plus M square plus N square is always equal to 1, right? When L square plus, when this is going to be the property that is existing. Then I can say K square into L square plus M square plus N square is equal to 1. Or K is equal to plus or minus 1 divided by root of L square. Sorry, I made a mistake. K into A square plus B square plus C square is equal to 1. Or I can say plus or minus 1 divided by root of A square plus B square plus C square. Then what I can say is L will be equal to what? Plus or minus A into K, that is A divided by root of A square plus B square plus C square. M will be equal to plus or minus B divided by root of A square plus B square plus C square. And N will be equal to plus or minus C divided by root of A square plus B square plus C square. Means, if the direction ratios are given to you, then they ask you to write the corresponding direction cosines, then this is the formula that you're supposed to use. Okay, the first exercise is all about building the relation between direction cosines and direction ratios. So if you're clear with this, I'll proceed.
Clear, sir.
Yes, sir. Clear.
The relation between direction cosines of a line L square plus M square plus N square is equal to 1. So if I want to find the direction cosines of a line passing through 2 points, I already gave it to you. So if the 2 points are x1, y1, z1 and x2, y2, z2, then x2 minus x1 is what? Is it direction cosine or direction ratio? X1, y1, z1. I have x2, y2, z2. I gave you a derivation, right? In which I got L divided by x2 minus x1 is equal to 1 by AB, if you remember. Right. Then this x2 minus x1 is what we call it as direction ratio. Guys, tell me one thing. Do you guys have a confusion of where to use direction cosine and where to use direction ratio? I've seen many of them getting confused. Do you also have that confusion? Not knowing which is direction.
Will it specify in questions, sir?
When it comes to question, if they give you a question, you'll not know whether those numbers are direction cosines or direction ratios, correct?
Yes.
So sometimes it happens, right? Okay. Listen to this carefully, okay? Cosine, cos alpha, cos beta, cos gamma, correct? Idella another direction, cosines. A, B, C are what? They are some numbers. Now, the point to be noted here is these numbers do not have any restriction. They can be any number. Whereas when you talk about cos alpha, cos beta, and cos gamma, they are cos functions. So when I say they are cos functions, what is the maximum value they can take, guys? They should be less than 1. Correct? So we know that the range of cos is less than 1, accepted? So when it is going to be less than 1, you need to have this cos mostly as a value less than 1. For example, you would have seen these questions. 2x plus 3y plus 5z is equal to 4. See, I'm directly jumping to the equation of a plane because I'm assuming you would have seen this. Okay. Then these coefficients are there, right? 2, 3, and 5. Are they direction cosines or direction ratios? Now you tell me.
Directional ratio.
Yes, they are direction ratios. Why? Because they are values greater than 1. You're able to understand? And secondly, what is the property that direction cosines follow? If they had been direction cosines, then 2 square plus 3 square plus 5 square should have been equal to 1, because there is a property L square plus M square plus N square is equal to 1, which is obviously not going to happen. So they are not direction cosines. Rohan, is that solving your problem?
Yes, sir.
To some extent, right? From next time, start thinking in this perspective. You look at those numbers. If you take those numbers and you need to apply this formula of L square plus M square plus N square is equal to 1. And if you don't get that 1, then those numbers are not direction cosines. They are direction ratios. That's it. Whenever this kind of a doubt arises, you keep doing this. Anyways, I'll be solving problems. At that point, you'll get more clarity. But as of now, I just gave you a hint. Okay, so when you have two lines that are joining, when you have a line that is joining 2 points x1, y1, z1 and x2, y2, z2, then x2 minus x1 is called as the direction ratio, y2 minus y1 is called as the direction ratio, and z2 minus z1 is the direction ratio. So if x2 minus x1, y2 minus y1 and z2 minus z1, these are the direction ratios, then how do you write the direction cosines? L will be equal to how much? Just now we saw the formula. If you know the direction ratios, how will you write the direction cosines? Plus or minus A, that is x2 minus x1 divided by root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Similarly, what will M be? Plus or minus y2 minus y1 divided by square root of the same stuff. N will be plus or minus z2 minus z1 divided by root of the same stuff. Is it clear? Right. So with this knowledge, we are ready to solve the problems of first exercise. So if I have a line which makes an angle 60 degree, 90 degree, 90 degree, 60 degree and 30 degree with a positive direction of x, y and z respectively, then we need to find the direction cosines. So what are the direction cosines? L will be equal to cos 90, M will be equal to cos 60 and N will be equal to cos 30. So cos 90 is 0, cos 60 is half, and N will be equal to how much? Root 3 by 2. Okay, for the same question, suppose they're asking you the direction ratios. Okay, you guys tell me what are the direction ratios. Make it fast. So what are the direction ratios? What are the direction ratios, guys? DRs will be 0, comma
1 by 2.
Half divided by how much? Square root of 1 by 4 plus 3 by 4. So, yeah, correct. 1 by 2 is right. And what is the next direction ratio? Obviously, it is root 3 by 2. Oh, sorry. I made a mistake. You can write the, it was my mistake. Sorry. If the direction ratios are given, then you can write the direction cosines. So given direction cosines are given, it doesn't make sense of you writing direction ratios because they can be anything.
Yes, we can't find it, right, sir?
No, you can't find it. I'm sorry. I just did the reverse. So what is the logic? Direction ratios are given. You can find direction cosines. Yes, possible. Direction cosines are there and direction ratios are asked. Not possible.
Sir, then 0, 1/2 and root 3/2 are direction cosine, sir?
Yeah, they're direction cosines now. So how, yeah, they're direction cosines. That's what the questions asked, no? Cos 90, you got. So how to, let's suppose, since you asked this question, suppose you have a doubt of that sort, right? Whether they are direction cosines or ratio. Always do this test, L square plus M square plus N square. In this case, 0 square plus 1/4 plus 3/4. So I'm getting 4/4, which is 1. So if L square plus M square plus N square comes out to be 1, they're direction cosines. That's it.
Okay, sir.
Okay, yeah. Now, the next question is possible. They've given the direction ratios 2, -1 and -2. Determine its direction cosines. So L will be equal to plus or minus 2 divided by root of 2 square plus 1 square plus 2 square, which is 9. So plus or minus 2/3, then you will have L will be equal to plus or minus -1/3 and N will be equal to plus or minus -2/3. Okay, next. You need to find the direction cosines of the line passing through the 2 points, -2, 4, -5 and 1, 2, 3. So how to find? What did they ask? Read the question carefully. Your job is to find the direction cosines of the line. So what have they given? They've given you the points. So first we will find the DRs. So what are the DRs here? X2 minus X1, that is 3. Y2 minus Y1, that is -2. And Z2 minus Z1, that is 8. So once you know the DRs to DCs is easy. So what are the direction cosines? 3 divided by square root of 3 divided by square root of what? 9 plus 4 plus 64. Similarly, -2 divided by square root of 9 plus 4 plus 64. 8 divided by square root of 9 plus 4 plus 64. What is the answer? 68 plus 9. 77. Huh?
Yes, it will be 3/√77.
So 3/√77 minus 2/√77 and 8/√77. Okay. Next is find the direction cosines of x, y, and z axis. That is, you have a line that is x-axis and that x-axis is aligned with itself at what angle? 0 degrees. It is aligned with y-axis at 90 degrees. It is aligned with z-axis at 90 degrees. So what will be the direction cosines? Cos 0, which is 1, cos 90, 0, and 0. So the direction cosines of x-axis is 1, 0, 0. The direction cosine of y-axis will be, don't put them in a bracket, okay? Don't put them in a bracket. If you put them in a bracket, it becomes the location, the point of that particular, so the coordinates of that particular point. Similarly, what will be the direction ratio of y-axis? So y-axis with respect to x-axis at 90, with respect to y-axis it is 0. That is alpha is 90, beta is 0, and gamma is 90. So 0, 1, 0. Similarly, when you talk about z-axis, it is 0, 0, 1. Okay. Fifth one. Show that the points are collinear. Right? So have this in your mind. If points are collinear, then the DRs of the line will be proportional and DCs of the line will be same. Do you understand what is the difference between both? That is, if you take the direction ratio of AB, BC, and CA, they might be same, they might not be same, but they will be in proportion. Whereas when you take the direction cosine of AB, BC, and AC, they should exactly be the same value. That is what I meant. What I'm trying to say here is show that the points are collinear. If suppose you want to solve the same problem using vectors, then what you can do is you can take A, B, C as position vectors and then find A, B, B, C, and CA. Then you can say the vectors will be in the same ratio. Okay. So you're doing the same thing, but you're not taking position vectors. So what is the direction ratio of AB? It is -1, -5, and -14. What is the direction ratio of BC? 2, 10. Sorry, BC is 2, 10. Wait, I made a mistake. Direction ratio of AB is 1 - 2 - 1 -2 -5. 3 minus of -4 is 7. Now I'll get -4. What is the direction ratio of AC? Direction ratio of AC is 1, 5, -7. Accepted. Now you see the direction ratio of AB and AC, right? How are they? They are in the proportion of -1. Correct? What about the direction ratio of AB and BC? They are in the ratio 1:-2. Are you able to understand? So the direction ratios will be in the same proportion, whereas the direction cosines will be in the same ratio. Is it clear, guys?
Yes, sir.
Yes.
Yeah, very good. So this is the first exercise which I want you guys to tell me how to solve. First one. What is the answer for the first one?
Use cos alpha, cos beta, cos gamma.
Cos 90 is 0. Cos 135 is -1/√2. Cos 145 is 1/√2. Find the direction cosines of the line which makes equal angles with the coordinate axis. So if it is making equal angle with the coordinate axis, then all the three direction ratios will be cos alpha, cos alpha, cos alpha. Now, what is the relation between all these three? Cos square alpha plus cos square alpha plus cos square alpha is equal to 1. So 3 times cos square alpha is equal to 1. So cos square alpha will be equal to 1/3 and cos alpha will be equal to plus or minus 1/√3. So what are the direction ratios of the line which makes equal angles with the coordinate axis? It is plus or minus 1/√3, plus or minus 1/√3, and plus or minus 1/√3. Okay. Third one, you can do it. If the direction ratios are -18, 12, and -4, what are the direction cosines? So it will be -18 divided by square root of everything. Then it will be 12 divided by square root of the square of everything. That is 18 square plus 12 square plus 4 square. And it will be -4 divided by 18 square plus 12 square plus 4 square. Fourth one, show that the points are collinear. What will you do?
We should show cos alpha, cos beta, cos gamma 0, sir.
Which one? For third one or fourth one?
Fourth one, sir.
Fourth one, find direction ratio. Why do you need to find direction cosine? Direction ratio is easier any day. Cosine is a headache actually with numbers. So you find the direction ratios. Then what are you supposed to prove? The direction ratio of AB, BC, and CA are proportional. If you're able to prove that, that is enough. Okay. Did you understand what I told?
Yes, sir.
Rohan. Right. Can you do that?
Yes, sir. We'll be able to do.
Not now. Fifth one, what are we supposed to do? Find the direction cosines of the sides. So whenever they give you numbers, the coordinates, and ask you to find the direction cosines, then always what you do is first find the direction ratio, then find the direction cosine. Okay. These two problems alone, I'm giving it as homework. And secondly, since this chapter is little heavy, okay, I need you guys to first master this before I proceed to the next exercise, which is tough. Okay. So in tomorrow's class, I'll be starting with the equation of line in a speed, and I might be taking some extended class also. Because this exercise is slightly big, I need to help you with a lot of problems. But before I start this, because direction ratio, cosine will confuse you. Inneke, go through this concept again and have clarity and come to the class tomorrow. Okay? Am I clear, guys?
Yes, sir.
Yes, sir.
Clear, right? Okay. And also revise your vectors and come to class. Tomorrow we will try to complete the second exercise. It is slightly big, but I will do it. Okay. So we'll try to complete it. Then we can do the third exercise, which is about the equation of plane. Okay. So that's it from my side for today. I'll see you all in tomorrow's class. Is there any doubt from today's class?
No, sir.
No doubts.
No doubt, sir.
No doubt, right? So please revise this exercise and complete. Okay. Whatever doubts you have, make a note of it. Divyesh, you can message
you,
me
sir.
the student support number.
Okay, sir.